Hello everyone, let's go over the next topic of today's lecture, which is C syntax and control flow. So C and Java have nearly identical operators. I've listed a whole bunch here, and you should be very familiar with these. Maybe the only ones that might be a little bit new are member selection, which is this arrow notation here, and this conditional expression right here, which is a ternary operator. So we can do like if sum expression, return this value, or return this value. So if it's true, do this. If it's false, do this. Here is a generic C program layout. So at the very top, we can see we have some system files, which are which are dumps of other files, like a header file, which tells information about another program or library. We have .o, which is an object file. So we have those types of things that it's defining up there. We also have the define statement, which is a macro statement, which is handled by the preprocessor, which will replace anything with this macro name with this macro expression. We also have possibly some functions that we want to declare, or some global variables or global structures. Remember that a function needs to have something declared before it is able to use it. So you might want to put function prototypes up here. Otherwise, a function that might be down below when it's called will actually know what that function requires to actually execute. Finally, programs that are executable must start at main. And main must always return an int in C. So typically, this return actually is the exit code that a program makes, so that is why it is actually important to have a return. And then below, you might define some other functions. I mean, it's up to you if you want to define them below or above main. It's really your choice. So here's an example of some C code where we will basically be printing out hello world 5 times. Repeat is, once again, a macro that is done by the preprocessor, as in it is replaced with 5 here because that is what we've defined it as. And printf requires this standard library import because this tells the system how it actually, or what it actually needs to do to print the string hello world. And here's an example of a for loop that you would use in C. Here's what happens when you first reach the for loop. Then every time the for loop finishes its body, it will execute this portion here, and then finally it will perform a check to see if it should continue to execute this body once again. So let's get a little bit more into the C syntax of main. So you notice that it took in 2 arguments. One was type int, and it was argc. One was type char star list, which is basically a pointer to a list of strings, or it's a list of strings, or it's a list pointing to strings essentially. So argc is essentially the argument count, so it contains the number of strings on the command line. So this is very useful. Don't forget it actually includes the file name that it is. And then there's also argv, which is an array containing pointers to the argument as strings. I'll get a little bit more into pointers. One other fun feature that they implemented with this is argv will actually always end in a null pointer. So the very last value that is in that array is going to be 0. So here's an example of, say I called the program foo with hello and 87 as arguments. I'd see argc is 3 because I have 3 arguments there, and my argv would contain foo as the first thing, hello as the second thing, and 87 as a string. Key thing, it's a string, not an integer, as the third thing. Technically, if I did argv of 3, it would actually return null or 0. But we'll cover a little bit more about these pointers and strings in a little bit. So let's go over some variable declarations. So all variables must be declared before they can be used. So typically you want to do this at the beginning of a code block so you don't have any issues. A variable may be initialized in its declaration, but does not have to. If you do not define what it is, that value is going to hold garbage if it is referenced before it's ever defined. So that is very important to understand. For example, this is a really bad imperfect analogy, but it's something that might get the point across. It's, say you get a new locker or desk at school. There might be leftover garbage that prevents you from actually being able to use the locker or desk because it's so disgusting. So that's why you need to be careful about and making sure that you actually set the right values first. So some examples of correct declaration is like int x. I'm just defining x to be an integer. I also have int a, comma, b is equal to 10, comma, c. So basically we're defining the type, and then we are defining the different variables and possibly initializing the variables as well. Some kind of exceptions to this is you can actually declare a pointer at the same time. So int a, and then I can put a star here so that I can do a pointer of, or b as an int star, which is an int pointer, and I can do c. The reason why I bring this up is because there are some incorrect things. Like if I define short here, all of these must be short of some type. But in this case, I'm saying x is a short while y is a float, so that's incorrect. The other thing is z is equal to this character here. I didn't define that z is some type, which is why this would also be incorrect. So no language is complete without Boolean operations. I mean, it's the true-false of life. But C is a little bit unlike Java and many other languages, as it does not actually have true Boolean types. Instead, C evaluates false to the value of 0, or null, but it only evaluates to false when those are met. So it will evaluate to true if it is not false, essentially. So anything that is non-zero essentially is true. This is the exact same idea as scheme, where the only false value is false and then anything else is true. Next, let's get into some control flow of C. So you should be very familiar with an if statement. It's very similar to many other languages. You have an if and then a parenthesis and then your expression and then an end parenthesis. And if this expression evaluates to true or some true value, or it's really just some true value because there is no type true, remember that, then it will evaluate this body statement here. You can also have if else. So if expression, do some statement 1. Otherwise, if this is not true, do some statement 2. Note that there is no if else statements. In reality, you would just do an if else statement and then put another if statement within that else body. Another thing you can have, or another way how you can actually control your program is with while loops. You can do a while this expression is true, do statement, or do this statement while this expression is true. The difference between these two is that the first one will execute the expression the first time it is actually is starting to execute this. So I will immediately execute this expression before I execute any of the statement, as opposed to this do statement while. This will actually execute this statement once before it actually checks this expression. So this can be very useful if you know that some while loop has to execute at least once. So this is the method that you actually can do it. So some more on control flow. So we also have for statements, which essentially is for some check. So basically, while this is true, we want to do this statement and then update something. So the very first time the for loop is called, we can initialize some value. In C99, we can actually initialize and define a type of a variable as well if we need to. So I could do like int I equals 0, and then every time this for loop is complete, I want to update something somehow, and then I want to check to see if something is still true. If it is still true, I'm going to continue to execute the statement. Otherwise, I am not going to execute the statement. There's also switch statements, which basically will evaluate some expression and then go into some cases depending on what that expression evaluates to. So if this expression evaluates to 1, I want to do case 1. If this expression evaluates to 2, I want it to do case 2. You can also add default statements, which are essentially statements which will run if no case is met. You can also break out of statements, which is a very important thing, which I will discuss next. So switching in C has a nice feature, which kind of could be a bad feature or misused feature, which is called breaking out of a case. So it's really called fall through, because what happens is, say I have case plus, case minus, case multiply in a default case. My case plus does not have a break statement, which means that if I have a character of a plus sign, that's going to execute both the body of the plus statement plus the body of the minus or subtract sign statement, as I only have a break right here. So this can be very useful if I know that the plus has to do like slightly more stuff than the minus, but the exact same stuff as the minus. But this can also shoot yourself in the foot, because say I now want to add the divide, so a slash here. I can put it right here, but maybe I forgot that the plus needs to use some of the minus stuff, so I might have just created it so then the plus will do divide plus minus. So that's not necessarily ideal. So it is pretty useful at times, but it can also be a problem if you do not actually realize what you've done, which often in C you don't realize what you've done until after everything's breaking and you have no idea what's going on. So some of you might be wondering, have there been any updates to C? Of course, yes, there have been, even though this language is ancient. I mean, it's pre-2000s. So in this class, we normally use C99 or C9X, and you can actually define it with GCC to actually run it. So if we add this flag standard equals to C99 at compile it on on compilation time, we'll actually be able to run with that variant of C. I've also included some references so then you can get some more information about C99 and C9X and what was changed. And I have a few highlights. I'm just going to quickly go over like one or two, like the for loops. They're more like Java, so you can actually do a declaration of variable in the very first expression, which is a very nice feature to have. And the other one that's notable is like you can add Java-like comments, so this double slash instead of having to do a slash star some comment star slash. So those are the basics of C syntax and control flow.